everyone. Welcome back to the live session. Today we will be learning about friction. Friction is a grade 8 syllabus. So today we are going to be discussing all about friction. Why is it caused? What is the factors that are depending on friction? And before we go ahead, let me first introduce you to Swiflearn. Swiflearn is 100% live and interactive classes. We have personalized attention batch. We give personalized attention to students with a maximum of 6 students in each batch. We also have a dedicated academic mentor team to track the progress of students, and also we do cover the syllabus according to the school exam schedule, and also we handle custom requests as well. Some of our key features include detailed progress reports. Swiflearn academic test series are conducted at regular intervals. We take unlimited practice tests and also subjective tests as per the school exam schedule. So with this, let us go ahead with our portion that we are going to be learning today. Before we go ahead, also do not forget to like, share and subscribe to our channel, and also click the bell icon to never miss any update about any live sessions. Yeah, so with this, let us go ahead. Today we are going to be learning about friction. It is a grade 8 syllabus that we are going to discuss today. So today we are going to be learning what is force of friction, what are the factors affecting friction. We'll be learning about the types of friction, which is static friction and sliding friction. And also we will be learning why is friction called a necessary evil. So that means why is friction advantageous as well as disadvantages. Yeah, so now observe this person who is pushing a car. Okay, so there is some force that he is applying, right? So we will call that force as applied force. Okay, since he is pushing the car, obviously he is applying some force. Yes or no? So that force is called as applied force. Okay, the force that you are applying. Now he is applying a force to overcome some other kind of force. Yes or no? Now observe the second case. In this case, the person is again pushing, again applying the same force, but in an opposite direction. Right? So there is some unknown force which he is trying to overcome. In both the cases, he is applying the force. This person is applying a force to overcome some kind of unknown force. Right? This unknown force is called as frictional force. Okay, and also as you can notice here, frictional force always opposes the direction of the applied force, meaning frictional force is always in a direction which is opposite to the applied force. Getting it? Once again, let me repeat it again. Frictional force always acts in the opposite direction to that of the applied force. Okay, now if the applied force is from left to right, then frictional force would be right to left. Okay, always frictional force will be in the opposite direction of the applied force. Now imagine if I am kicking a ball. Okay, I am kicking a ball from right to left side. I'm kicking. Okay, so frictional force is acting on which direction? If I am kicking a ball from right to the left side, then frictional force is acting from the left to the right side. So whichever direction is the applied force, the frictional force will always be in the opposite direction. Okay, now what is frictional force? What is it that is acting in the opposite direction? Well, imagine you are kicking a ball. Okay, now you kick a ball, the ball starts rolling in the ground. Okay, it keeps on rolling. Now, after some time, what happens? Even if you are not applying any external force, also, after some time, the ball will automatically stop. It will stop rolling. Yes or no? Even if you're not going and picking up the ball, if you're not applying any external force to the ball, also, after some time, the ball automatically stops, right? How is it stopping? Because of frictional force that is acting on the ball, and this frictional force is acting on the opposite side. Whichever side I am kicking the ball, frictional force is acting on the opposite side. Okay, now moving ahead. Also, students, if you have any doubt regarding the what I am teaching you, you can send me a comment. You can send me your doubts in the comment section. I will definitely read them and try to clear your doubts. Okay, yeah. So moving ahead, the force of friction is a force that always opposes the applied force. This is what we were discussing, right? Whichever direction the force is applied, frictional force always acts on the opposite direction. Okay, moving ahead. Now, the speed of the ball reduces. This is the example that I gave you earlier. When you kick a ball, it starts rolling. After some time, the speed of the ball starts, reducing, right? And after a while or gradually, what happens? The ball stops rolling, right? How is it coming to rest? Unless and until there is a force that is applied on the ball, it will not come to rest, right? No object will change its state of motion or rest unless an external force is acting on it, right? So if the ball is coming to rest, that means some kind of force is being acted on it, right? And this force is called as frictional force. It always Frictional force always works in the opposite direction of the applied force. Okay, now a vehicle slows down when brakes are applied, right? Now, not only vehicles, any object moving over the surface of one another, right? Any object that is moving, right? For example, if you're considering a vehicle is moving on top of a road, right? So the wheels of the vehicle and the road are in contact with each other. Yes or no? So even if you don't apply any brake, after a while, if anything it is moving, it stops on its own, and this is because of friction. Okay, now friction, now force, there are basically two kinds of force. Okay, there is frictional force, there is contact force and non-contact forces. Okay, so basically all the force is divided into two. Okay, there is a contact force and there is something called as a non-contact force. This one you must have learned in your junior classes as well. Contact force means when both the objects are in contact to each other, and if the force is applied in contact to each other, then it is called as a contact force. Non-contact force is when both are not in contact to each other, like gravity, right? Even if the both objects are not in contact to each other, still gravitational force can work out. So frictional force is a type of contact force. That means frictional force will not work out unless and until both the objects are not in contact with each other. Okay, so both the objects should be in contact to each other for frictional force to act. Okay, now if a ball is rolling over the ground, the ball is the object and it has to be in contact with the ground. Unless and until the ball and the ground are not in contact, frictional force will not happen. Okay, both should be in contact, because frictional force is a type of contact force wherein it requires that both the object are in contact with each other, then only it works. Okay, so the force of friction is an opposing force that acts between the surfaces in contact. Moving ahead. Now imagine you're walking and there is a banana peel on the floor. Okay, and you step on the banana peel. What happens? You will slip and fall down. Yes or no? Now, also, in some cases, it is difficult to walk on a wet floor as compared to a dry floor. Right? If the floor is wet, it is difficult to walk on it. Why is this happening? Why is it that when you press your foot on a banana peel, you slip? Or why is it that if you apply a little oil on the floor and if you walk, you will definitely slip? Yes or no? Why is this happening? right? Why is this that it is much easier to, imagine there are two surfaces, okay? One is a rough surface and one is a smooth surface. Imagine two surfaces like a one surface is rough, it has a lot of irregularities and rocks and stones and all, and one surface is a marble floor, okay, it's smooth. Now imagine you are pushing or dragging any object, your luggage or anything in the floor. Okay. Now, which is more difficult? Is it difficult to drag an object that is in the smooth, that is in the marble floor? Or is it difficult to drag an object which is in the irregular, the rough floor? Which will be more difficult? Obviously, it will be the rough surface that is difficult. Yes or no? So, as we know that the force of friction acts between two surfaces in contact, thus, in all the cases that we discuss now, whether it's the banana peel or a wet floor or a rough surface or a smooth surface, in all these examples, friction is not the same in all the surface, right? In the rough flow surface, friction is more, right? It is more difficult to push or drag something, right? Friction is more. Now, in a smooth surface, the friction is less, right? When you step foot on a banana peel, friction is reduced there. That is why you slip, right? Now, if you are walking on an oily surface, friction is less. So there are chances that you will slip. If you're walking on a wet floor, it's more difficult than walking on a dry floor. Why? Because in a wet floor, the friction is less, right? So based on all these observations, we can say that the factors that are affecting friction are one, the nature of the surface, and number two, how hard the surface is pressed together. Okay, we'll repeat it once again. There are two factors on which friction is depending. Okay, one, the nature of the surface in contact. Okay. Now, whether it's hard, it's rough, it's smooth, what kind of a surface is it? Okay. And next point is how hard the surface are pressed together. Now, let us understand these two lines a little more, these 2 points a little more better with the experiment. Okay. Imagine or take an object, okay, any object. Here I have taken this object, which is like a wooden block, okay, and now I am tying it with a spring balance. Okay, so now I'm tying it with a spring balance and then I am placing it on a surface. Okay, and now I am, it is a smooth surface as you can see, right? The surface is quite smooth. Okay, now I am pulling the object as you can see here in the diagram. I am pulling this object through the by the spring balance. Okay, and as I'm pulling this reading of the spring balance, I'm noting down the reading of the spring balance just when the object starts moving. Okay, I'm repeating it once again. First, you take an object, tie it with the spring balance. Okay, now pull the object by the spring balance. Okay, now the reading on the spring balance, just when the object starts moving, gives the measure of the force of friction between the surface of the object and the wooden surface. Getting it? Now, as I am pulling it, as soon as the object is starting to move, okay, whatever reading is shown on the spring balance, that is equal to the force of the friction, the frictional force between both the objects. Yeah. Now in the second case scenario, that was the first case. Okay, so I put an object, I took a spring balance, I plugged it, and I note down the frictional force. Okay, now in the second case, I am taking a jute cloth. Now, jute cloth is a very rough cloth, right? So I'm taking a jute cloth, covering this table, the smooth table. I am covering with this hard jute cloth. Okay, now I am placing the wooden block, tying it with the spring balance and pulling the spring balance. Now, do you think it will be harder or the frictional force will be more? Or do you think whether the frictional force will be less? Right? Think, what do you think? Now it would be more difficult to pull the surface on a rough surface, right? To pull the object on a rough surface, it will be more difficult, right? And we also know that the reading in the spring balance give you the measure of the frictional force between both the objects, right? Now if you see, it is noticed that the smooth surface is less force required, and the rough surface needs more force to pull the object. Okay, so a greater force is required to move the object on a rough surface as compared to that on a smooth surface. Is it clear? Right? So they both the surface will have a particular type of difference, right? It will not be the same. The frictional force in the first case will be different from the frictional force in the second case. In the second case, that is when you cover it with a rough surface, right? When you cover it with a jute cloth, which makes it a rough surface, the frictional force is more as compared to the first case, right? I hope this is clear. Now, moving ahead to spring balance. Now, spring balance is basically we used in the previous experiment. Let us just learn a little more about how spring balance works. This is how a spring balance looks. Okay, it is a device that is used for measuring the force acting on an object. Okay, it will tell you the force, the amount of force that is acting on an object. Okay, so when a force is applied to it, the coil, so see here, you can see here inside there would be like spring. Okay, it's like a coiled spring is present inside. Okay, this coil spring starts stretching when you keep an object here below in the hook. The spring will start stretching, and the pointer, see, this is the pointer moves according to the stretching of the spring, and the reading on the scale will give you the magnitude or the quantity of the force. This is how a spring balance works. Okay. Now moving ahead, now friction depends on nature of the surface in contact. Okay. Now how does that happen? We we discussed 2 points, right? We discussed two factors on which frictional depends on. What are the two factors? Try to recollect the two factors on which the force depends on. One is it depends upon the nature, right? Nature of Yeah, sorry, there was a small glitch. Okay, now that we are back, let me start. Yeah, so we were discussing the 2 points on which the friction depends upon, right? So try to recollect the 2 points on which friction depends on. One, it depends upon the nature of the surface, and number two, it depends on how hard the object is pressed to each other, right? So we already did an experiment to show that in a hard surface, the frictional force is more. See, you can see the diagram over here. We are taking inclined positions, right? There are three inclined positions that I'm taking here, and I have kept it same. Okay, in the all the three cases, the degree of inclination is same. Okay, now I am taking a small cart and I'm rolling it over. Okay, and see, the surface is different. This is a very irregular or a very rough surface. This is intermediate. It's not very rough, it is not very smooth. And in the third case scenario, I have taken a very smooth surface. Okay, the third case, I've taken a very smooth surface. So basically, the degree of inclination is the same, but I've taken three different surfaces. In first case, I took a very rough surface. In the second case, I have taken an intermediate surface. In the third case, I have taken a very smooth surface. Okay, now I am putting the cart over the inclined thing. I'm putting the cart. Okay, now this for a long distance, it stops. Okay, now in the intermediate, that is not so hard but not so smooth, in such kind of surface, when I put the cart, what happens? It is moving. Comparatively, the frictional force is less than the first case, but still it's not very high. In the third case, I've taken a super smooth surface, okay, and I have put the cart down, and the cart moves for a longer distance. This means what? The friction is very less, right? If friction is very less, it can move easily, right? So now this, by this we can understand better that friction depends upon the nature of the surface in contact. Okay, now moving ahead, friction is caused by the irregularities on the two surfaces in contact. This is the cause for friction. Why is friction happening? It is because of the irregularities. When two surfaces are moving over each other, some irregularities, there are some minute, okay, like we cannot see some, in some cases you cannot even see through your naked eyes. That much minute irregularities are there. So these irregularities will interlock with each other. Okay, so that is why friction is happening, because these irregularities are getting interlocked with each other and it is difficult for it to push further. Okay, so this is why friction happens. Why? Because of irregularities between two surfaces, and because of these irregularities, interlocking between the surface will happen, and that is how friction, that is why friction is caused. Moving ahead, surfaces which appear very smooth also have a large number of minute irregularities on them. We might not see them with our naked eyes, but there are. Even in a very smooth surface, there are. In rough surface, obviously, the irregularities is a lot more. Now, because of these irregularities on the surface, force is required to overcome these irregularities. Okay, these now when there are irregularities, as I said earlier, when there are irregularities, these irregularities interlock with each other, right? So, because of these irregularities on the surface, force is required to overcome these irregularities that lock into one another, which is called interlocking. Interlocking is nothing but locking of these irregularities. So the applied force, whichever force you are applying, should overcome this interlocking. Okay, on rough surface there are large number of irregularities, so the force of friction is greater, right, if a rough surface is involved. In a smooth surface, the irregularities are less, so force of friction is less, right? I'll repeat it once again. In a rough surface, irregularity is more, interlocking is more, and frictional force is more. So more force is required, or more force you need to apply if you have to overcome the frictional force. Now in a smooth surface, it is smooth, irregularities are less, interlocking is less, right? Frictional force will be less because of that. So if you pull something, you don't need much of force to push anything in a smooth surface. Is that clear? If you have any doubt, you can send me in the comment section. Okay, now moving ahead, we will do another activity to see that friction depends on how hard the surface are pressed together. Okay, now I have taken two cases here. I have taken two boxes of the same weight. Okay, in this case, I have taken only one box of the same mass. Okay, so in the first case, I have taken two boxes of the same mass, and in the second case, I have taken only one box of the same mass. Now, I am trying to push it. Now, tell me which one will need more force to push? Which one do you think requires more force to be pushed? Obviously it is the first case, right? In first case, because mass is more, it requires more force to be pushed. Why do you think it requires more force? Because frictional force will depend on how the object are pressed on the surface. Now, this one will be pressed more hardly on the ground. This one, in the second case, it's pressed to the ground, but not as hard as the first case, right? So, depending on how hard, if the object is very hardly pressed on the surface, then frictional force is more. So, you need more force to push it. But in the second case, the what do you say, this the object is not very hardly pressed onto the ground, so it is easier to overcome the frictional force. Okay, so this happens because of the interlocking of irregularities between the two surfaces. Okay, now this makes it more difficult to move a heavier object on the ground as compared to a lighter one. Okay, a lighter object does not press harder to the ground, so the interlocking between the irregularities are less, so it's easier to push. The applied force is less applied forces required. Okay, now we will do a small simulator to understand the direction of the various forces that are acting on an object. Okay, so now here you can see the arrows. Okay, now this person is going to move this box. Okay, this person is trying to move. So this surface over here is wood. Okay, this brown color surface that you see is wood. Okay, now these are brick walls. Okay, now a person is standing here and he is planning to push this. So this is the applied force. You can see here how much hard he is going to push. Now force, the unit of force is Newton. So now I've put 25.96 Newton. The object is not moving very fast, right? Now I apply more force. Okay, now if I'm applying more force, what happens? The object starts moving with a greater force. Now, pay attention here. This is the direction of the applied force, right? This is the direction of the applied force. And this is the force of gravity acting. Fg here is a force of gravity that is acting here. Okay. Okay. Now see, we are going to see a graph. Okay. Here in these walls that you can see here, in these walls, I am going to be applying springs. Instead of applying a brick, instead of putting bricks here, I am putting springs here. Okay, see here you can see I've put springs here, and instead of, see, obviously it is difficult to push an object on a see, I have taken two objects, two surface. Okay, one is a wood. Okay, in wood it's a lot more difficult to push an object, right? See, it requires more energy or more force to push an object when it comes to a wood. Now I am changing this wood and I am applying another surface. Okay, let's say I am applying ice. See, now I am applying ice. Now here the friction would be very less because it is a lot more smoother than wood, right? Irregularities are less. So it's easier. See, within a very little force, the object can move. Okay, now I will apply springs. And yeah, so here I've applied springs. Okay, and now I'm going to push this object. Yeah, I am pushing. Okay, the object has started moving, but since the frictional force is more, it is taking a lot of time. So I am going to push it harder. As you can see here, I'm pushing it harder here now. Now I'll change the wood and I'm applying ice here. What happens? It is easier, right? In the ice, the friction is less, so it is easier to push object when it comes to ice. Okay? Yeah. Yeah, so in this experiment, what did we see? We saw that wood and ice, we took two surfaces. In wood, it is compared to ice, it is difficult to move anything on wood because ice is smoother, irregularities are less, right? So the frictional force is less in ice, so it's easier. With a very few newton of force, you can push in ice, right? But in wood, it's a lot more difficult. And now, since I have applied springs here, see, it is bouncing back. Right now, if I don't apply springs here, do you think it will bounce back? No, it wouldn't bounce back, right? There's no applied force. It just goes and hit the brick wall. Now, there is a small crossword puzzle that I want you all to try doing. If you know the answers, please send it to me in the comment section. Okay, now the force, the opposing force which resists a motion is called as dash. The opposing force which resists the motion, okay, here, what is it called as? You can send me in the comment section anyone surface which offered more resistance. Try to solve the puzzle. Yeah, so a cause which changes the state of motion. What is required to change an object from its state of motion? Okay, now also a change in force of friction. If irregularities of the surface increases, what happens? What happens to the force of friction if irregularities will increase? Pushing force, it is friction. Look at the crossword. Look at the crossword and try to solve it. Yeah, but you are very close. It is pushing force is basically applied force, not applied force. Here we are talking about frictional force. Okay, so the opposing force which resists motion is friction. Surfaces which offer more resistance is a rough surface, right? Smooth surface is easier. To push anything on a smooth surface is much easier, right? Now, a force which changes the state of motion is force, right? You require a force to change any object's motion. Now, a change in force of friction if irregularities of the surface increases, right? Surface which offers less resistance is smooth. Surface which offer high resistance is rough. Okay. Moving ahead, this is a small activity. If you have any siblings at your home, you can try doing it. Okay, first what you do is take a mat, okay, a normal mat, a door mat or something, and try to drag it on the floor. Okay, now make your sibling, your young sibling, to sit on this mat and you try dragging. In both the cases, which one will be difficult? It will obviously be, just tell me which one will be easier to move, and yeah, which one would be difficult in this case? It would be when your sibling is sitting on it, you are pulling it, dragging it, it would be more difficult, right? Why? Because it presses more to the surface. So friction is more there, right? Because it's pressed more hard to the surface. So friction will be more. So it is more difficult to drag when your sibling is sitting. Then nobody is sitting. When you are just dragging a mat, what happens? Frictional force is less because it's not pressed very hard to the ground, so frictional force would be less. Now another thing to think is, Tell me which one is easier, okay? To move an object from rest or to move an object which is already in motion. Which one do you think would be more difficult? It would be, any idea? See, try to learn the concepts and answer. Okay, see, we know that friction is caused by the irregularities, right, between two surfaces in contact, right. When an object is at rest position, the force is required to overcome the irregularities that lock in one another. I'll repeat it once again. Imagine an object is stable, that is, it is at rest, and one object, it is keeping on moving. Okay, now if I have to push this object, if I have to push, already this object is stable, it's not moving, so it had the time to interlock. The irregularities between this object surface and the ground has more time to interlock with each other, right. So it is interlocked, so now to push it, it will be very difficult. But now this object is already moving, so the time for interlocking with the irregularities is already less there, so obviously it would be easier. Getting it? If you have any doubts, please ask me. Okay. Okay, so an object, when the object is already in motion, the contact points on its surface do not get both the surface that are in contact, okay, those points do not get enough time to lock with each other, right. They don't get enough time to lock with each other. Thus it is always easier to move an object which is already in motion than to move an object which is from rest. Now, there are two, based on this, what we discuss right now, there are two kinds of friction. Okay, one is static friction and the other one is sliding friction. Okay, there are two types of friction. One is static friction and the other one is sliding friction. Now, the force required to overcome friction at the instant an object starts moving from rest is called as a static friction. That means now an object is at rest. Okay. Now if I'm trying to push this object, the force that is required to push this object, right, to overcome the friction as soon as this object starts moving, that is called as static friction. So what is static friction? When an object is at rest and when you try to push it, the friction that is applying on this object is static friction. Now coming to sliding friction. Now an object is already moving, an object is already sliding, or an object is already in motion, right. Imagine an object that is already in motion, okay, and you are trying to push it, right. So which force is acting on this object now? Sliding friction. The only difference, both of them are friction, okay, the only difference between both of them are, one is rest. When an object is rest and you're trying to push it, the force acting on it is static friction. An object is already moving and you're trying to push it, apply force on it, then it is sliding friction. And we know that it is a lot more difficult to push an object that is in rest as compared to an object in motion. That means the friction is more in in static friction, right. Static friction is more than sliding friction. So static friction will always be greater than sliding friction. Clear? Now, there are a few questions that I want you to think about so that you all try to recall what you learned today. Okay, there are three questions that I've given here. Try to recall them. One is, what is force of friction? Try to recall what is force of friction. The opposing force that is acting on an object, right, is called as force of friction when both objects are in contact with each other. Now name the factors that are affecting force of friction. There are two factors. One is the nature of the surface in contact, and number two is how hard the object is pressed to the surface. Okay, now there are two kinds of friction. One is static friction and sliding friction. Now try to differentiate between both of them, right. The force that is required to overcome friction at instant an object starts, when it is in rest and when you try to push it, the force acting on it is static friction. When an object is already moving and you try to push it, then it is sliding friction that is acting on the object. I hope this is clear. If you have any doubts, you can send it to me in the comment section. Moving ahead, now friction is always said to be a necessary evil. Necessary means what? Something that is very necessary to us is called as a necessary thing. Evil means what? Something that is having a lot of disadvantage, right? Something that is bad is called as evil. Now friction is always said to be a necessary evil because it has a lot of disadvantages, but yet it is very necessary for us. Without friction we cannot do anything. We cannot write, we cannot walk, we cannot run, we cannot jump, we cannot do anything without friction. Right now, if I want to write, there should be friction between the nib of the pen and the paper. Otherwise, I cannot write. If I want to walk, there should be friction between my feet and the ground. Otherwise, I cannot walk. Right? So, holding, walking, writing all requires friction. All these important activities require friction. Without friction, we cannot hold, we cannot write, we cannot walk, we cannot run, we cannot do anything. Right? Now, I'll give you an example. Okay. Now, if I hold a glass, right, I'm holding a glass. I'm holding it because of friction. Now, oil or grease, no, they reduce friction. Okay, so I am applying oil to the surface of this glass. Now I am trying to hold the glass. What happens? It is a lot more difficult, right? It will slip. The glass will slip from your hand because of oil. There is no friction. So these oil and all reduces friction. Okay, so now another few advantages of friction include lighting a matchstick. That is friction between when you light a matchstick, the friction between both the surface is the reason why it fires up. Okay. Now fixing a nail on the wall requires friction. Now brakes use friction to stop the vehicle. Now, these are some of the advantages of friction. Now, let us discuss the disadvantages of friction. Okay. Now, wear and tear of moving parts of machinery happens because of friction. Okay. Now, like imagine you're wearing a chappal. Okay. You've bought a new shoe or chappal. You're wearing it. It works well for the first few months, maybe a year or two. After that, what will happen? The sole of the chappal or the shoe will get damaged, right? Why does your chappal damages, the sole damages? It is because of friction. Between when you're walking, there is friction force applied on the surface of the shoe or chappal and the ground. Okay, so because of this force, frictional force is always in the opposite direction, right? So because of that, it wear and tear of machines or damage of soles of shoes, all that happens. Okay, now when a machine is operated, heat is generated a lot, right? In some cases, when you are working out a huge machine, a lot of heat is generated. This is heat energy, this is loss of energy, okay, in the form of heat. That is because of friction, which is a loss for us because we are losing energy in the form of heat. Moving ahead, could you tell some other disadvantages of friction? Well, friction creates noise pollution. Like whenever you see this construction work or whenever you go to factories, there's a lot of noise, right? Why do you have that so much noise? Because of the machine's parts, because of the friction between the machinery parts. Okay. Now, another one, it makes another disadvantage is it is because of friction that two surfaces are hard to move, right? To move over each other, it's hard because of friction, and as a result of that, it slows down speed, right? It slows down speed. If there's any machine or something, because of friction, the speed or the efficiency of the work slows down. Now, few question and answers for you people to understand how much you have gained from this lecture today. Mark the direction of the frictional force in the image. So this guy is pushing a tire. I want you people to mark or to understand in which direction would be the frictional force. That is the first question. Now, second question, I have given few materials. One is a jute cloth, a wet marble floor, newspaper, and a dry marble floor. You need to arrange these surface as per the increasing order of the force of friction acting on them. Okay, if a car is moving on it. Now, the answer for the first question is, if he is pushing this side, then obviously frictional force will be opposite. So frictional force would be that side. Okay, now if I am pushing something this side, frictional force would be this side. This is frictional force if I am pushing something. Always frictional force will be opposite to the direction of applied force. Okay, now in the second case, see, friction will be more if the surface is rough, and it will be less if the surface is smooth, right? We know that already. So wet marble floor, friction will be the least. Then comes dry marble floor, because even though it is dry, it is a marble floor which is smooth. Newspaper is not as smooth as marble floor, so that comes next. And friction will be the most in jute cloth. Why? Because it has a very hard surface. Okay, so these are some of the points that we discussed today. We saw that what is force of friction. We saw the types of friction, which is static friction and sliding friction. Okay, try to recall which is greater, static or sliding. It is static friction that is greater than sliding friction. Why so? Because in static friction, the object is at rest. Right, so the object has got a lot of time to interlock with the surface in contact. So it is more difficult to push anything that is on rest, right? But in case if when an object is already in motion, it is having less time to interlock with any irregularities because it is continuously moving. So static friction is always greater than sliding friction. Okay, another few factors affecting friction we learned, which is the nature of the object and how hard the object is pressed to the surface, we learned. Then we learned that friction is a very necessary evil. Friction is very necessary. Why? Because without friction, you cannot walk, you cannot run, you cannot drive any kind of vehicle. If you kick a ball, it will never stop. It will keep on rolling. You cannot hold anything, right? You cannot do anything without friction. But it is evil because there are a lot of disadvantages. The soles of the shoe gets damaged because of friction. You lose a lot of heat energy in machineries because of friction, right? Wear and tear of machinery parts happens because of friction. So these are some of the disadvantages of friction. That is why friction is called as a necessary evil, because it's very necessary, but it has a lot of disadvantages as well. So this is all for today's session. If you have any doubt, you can send it to me in the comment section. I'll wait for another 1 minute to see if anyone has any doubt, or else we'll sum up with today's live session. I hope you all enjoyed the live session as much as I enjoyed teaching you people. Also, to avail any free trial classes, you can go to www.swiflearn.com. It is given here below in the screen, you can see. Okay, and also if you want to write to us, you can go to support@swiflearn.com. That is our mail ID. If you want to get in touch with us through call or WhatsApp, the numbers are given in below the screen. You can have a look and get in touch to us. We conduct, personalized classes as well, with a maximum of 6 students per batch. Okay, and we also we handle any custom request also. There is a academic team that teaches you and also mentors your or your progress as a student. How are you improving? And also we provide points on where you can improve better. We don't teach you what to learn. We teach you how to learn in our classes. So if you're interested, you can go through our website and you can check a few. There are a few trial classes. You can attend trial classes and then decide if you want. Trial classes are basically free. Okay, so you can attend free trial classes and then you can decide if you want to join for your academic year, if you want to join. Yeah, so this is all for today's class. I think this is done. Okay, so thank you everyone. I'll see you again in the next class. Bye bye.